So a lot of these solutions end up being electrolytes because if we have a strong acid or a strong base, they dissociate completely. Even if we only have a weak acid or a weak base, they don't dissociate completely, but they still dissociate some. And so as long as I have a mobile charge, I can conduct electricity. The resulting salt solutions are usually good electrolytes as well. So let's take a look here. So again, for electrolytes, we need to have mobile charge. And so if I have something that in solution dissociates into ions, I have mobile charge. And so I am able to conduct electricity. Okay? If I have a strong electrolyte, I have a lot of ions in solution, I can get a really bright light bulb. If I have a weak electrolyte though, I'm not going to have as many ions in solution. Weak electrolytes do not dissociate completely. They stay mostly molecules. So I only have a few ions in solution. So if I try to light a light bulb with this, it'll light, but because I don't have a lot of mobile charge, I only get a little bit of light on the light bulb. Okay? Now, when we take this into consideration with acids and bases, strong acids pretty much completely dissociate into all ions. Weak acids, though, only slightly ionized. We get a little bit of ion formation, but we mostly have intact molecules. So, which one's going to make a better electrolyte? The strong acid or the weak acid? If you said the strong acid, you were correct. Okay, and we can visualize this. So here is a dissociation for a strong acid. All right, so before dissociation, I have all acid molecules. Once you put it in solution, it dissociates, and now you can see my after dissociation diagram. I don't have any of my original acid left, but I have all ions. Okay, but in contrast, with a weak acid, before dissociation, I have my acid, but after dissociation, so this was before dissociation right here, okay? After dissociation, you can see a few ions formed, but not very many. Okay, and so we get not a whole lot of mobile charge there. Okay, and so here I have two solutions. I have a hydrochloric acid solution and I have an acetic acid solution. Okay, so this one, the HCl, this is hydrochloric acid. This one's acetic acid. Okay, hydrochloric acid is a strong acid, acetic acid is a weak acid. So looking at these pictures here and knowing that hydrochloric acid's a strong acid and acetic acid's a weak acid, which one's the better electrolyte? Ah, the hydrochloric acid. Okay. Now, there's not a whole lot of strong acids and strong bases. There's just a few. The rest of them are weak. So it's really important to recognize the strong acids and strong bases. These you should know. These are not things that you should be turning to a list of notes all the time. You really need to memorize and know the strong acids and strong bases. Everything else is a weak acid or a weak base. There's only a few strong ones. And so that recognition really helps if you know it right off the top of your head. So you should memorize your strong acids and your strong bases. Okay. So when I look at those, soluble salts tend to be strong electrolytes, strong acids, strong bases, strong electrolytes, and then our weak electrolytes would be our weak acids and bases. Okay, and then we would get some non-electrolytes in the form of things like insoluble salts. Okay, now maybe you get a tiny bit of dissociation, so maybe you'd see a tiny bit of the light bulb light up. It just depends on how much of it you're trying to put in there. So, okay, and then when we look at salt solutions, those resulting salts, okay, some of them give us a neutral solution. A lot of them give us a slightly acidic solution, and some of them give us a slightly basic solution. Okay, and so that has to do with what's reacting with the water. Because if I have a weak acid or a weak base, and I do a reaction, I end up with those ions. And so the thing with weak acids and weak bases is everything exists in what's called an equilibrium. And so I have a forward reaction and I have a reverse reaction for these guys. And so my reverse reaction will reform my original weak acid or weak base, and it'll do that by reacting with water. And so it'll then end up messing up the hydronium or hydroxide in water. And so we end up with either an acidic or a basic solution. So it depends on if you're looking at the anion or the cation of a strong species when you deal with the pH of salts.